So good evening children. As you can see the time is 8:10 p.m. today. Lecture number 11 for amine. Chemical properties we are discussing in the amines. Lecture number 11 is already uploaded. Now lecture number 2 I will upload soon. So chemical property reaction with nitrous acid. So first reaction with nitrous acid. What is nitrous acid children? Nitrous acid is HNO2, that is called nitrous acid. So how to prepare nitrous acid? First we have to prepare nitrous acid. It is prepared by NaNO2 plus HCl. From here HNO2 nitrous acid plus NaCl. HNO2 plus NaCl will be formed. So we need freshly prepared HNO3. So in the reaction we have to take NaNO3 and HCl, then only it will be performed. In that case RNH2, that is our 1 degree amine children, reacting with HNO2, above the arrow NaNO2 plus HCl you have to write, because freshly prepared this HNO2 we need. In that case R N2 positive Cl negative will be formed. It's called alkyl diazonium chloride. It's called alkyl diazonium chloride. Next topic, this diazonium salt only, separate portion we will discuss. So here it is one of the preparation method of alkyl diazonium chloride. In that case, if you are introducing water H plus and OH minus, so what happened in that case? Then N2 will release and H plus and Cl minus, HCl will release, and finally it will form alcohol. Alcohol formation will be done. Okay. So one more example. If C6H5 NH2 is given, here above the arrow NaNO2 plus HCl, from here HNO2 will be formed, and the product is C6H5 N2 positive sign, Cl negative sign. What is benzene diazonium chloride? Benzene diazonium chloride will be formed. So that is the process for reaction with nitrous acid. And this benzene diazonium salt, this benzene diazonium chloride, we will discuss completely in the second phase of the chapter. Okay, so let's discuss about the mechanism of this concept. So here mechanism of HNO2 reaction. Mechanism of HNO2 reaction. So be with me. So oxygen, double bond, nitrogen, single bond oxygen, then hydrogen. This oxygen is having lone pair. HNO2 and basic medium already H plus and Cl minus we are having in the solution. So this H plus approach the oxygen, because oxygen is having lone pair, and it will be converted into oxygen double bond nitrogen, then oxygen, one hydrogen, and second hydrogen, and hydrogen is getting positive sign. Very interesting species is formed. Now, children, simply you have to remove water. These electrons shifted here, and from here, water will be removed. So, what you are getting now? Oxygen, double bond nitrogen, and positive charge will be on the nitrogen because it is donating electron. And here, lone pair on the oxygen present. Because of that, it is working as a electrophile. Octet of nitrogen, oxygen is not completed, so it is working as a electrophile. It is called nitrosonium ion. Nitrosonium ion. Nitrosonium ion is formed. Then RNH2 lone pair plus nitrogen positive charge double bond oxygen. Here lone pair attached with the positive charge, then you are getting Rn, two hydrogen with nitrogen, then nitrogen is giving electron, then positive charge, double bond oxygen. So hydrogen will give sacrifice and positive charge of nitrogen will be vanish. So Rn hydrogen and nitrogen is having double bond oxygen. In the next case, what happened? H plus transfer, children. H plus see these electron shifted here. Hydrogen is free. Oxygen electron shifted here, and oxygen will attach to the oxygen. Hydrogen will attach to the oxygen. Once again, I am telling you, these electrons shifted here. Pi electrons shifted on oxygen, then hydrogen will attach to oxygen. So what we are getting? R, then nitrogen, double bond nitrogen, and OH is attached. Oxygen is having lone pair. H plus in the solution we are having that H plus again approach the lone pair, and again Rn double bond N, and again OH2, oxygen is having positive sign. Again children, water species will free, it will take electron, and water species will be free. So from here again water remove. In the next case, if you remove the water, then what it is? Rn double bond and nitrogen, it is donating electron, then positive sign. This time lone pair also have. These lone pairs shifted here, and Rn, now this time this nitrogen is donating triple bond nitrogen, and Cl is free everywhere. This Cl, it will be attached. So this is your alkyl diazonium chloride. Alkyl diazonium chloride. So this is the complete mechanism. Once again children, I am telling you, here this is your O NOH, HNO2 basically, H plus and Cl minus we are having. So lone pair attached by the positive charge, then it is forming this water species. By the electron taking, that water species will leave, and it is forming nitrosonium ion. Oxygen is octet is not completed, it is working as a electrophile. Then amine nitrosonium ion, this nitrogen is having lone pair, positive charge attack. So this nitrogen is donating, then positive charge here, 2 hydrogen, NO. In the next step, children, positive charge will be vanished by the sacrifice of this hydrogen. And in the next step, H plus transfer will be done. How it will be done? These electrons shifted here, these electrons shifted here, and hydrogen will attach to the oxygen. Then ultimately you are getting this species. Again one H plus will approach the OH, and again water species will be free. This nitrogen is donating, so here positive charge generated. And this is lone pair, again they will convert it into triple bond, and your alkyl diazonium chloride is formed. So that's all about the mechanism. At the same time, one more reaction I will explain. So check it once. What is the reaction? Reaction with aryl sulphonyl chloride. Very important. Reaction with aryl sulphonyl chloride. Reaction with aryl sulphonyl chloride. Aryl sulphonyl chloride. What is aryl sulphonyl chloride, children? C6H5 sulfur sulphonyl chloride, SOCl2, and aryl is attached, Cl. It's called benzene sulphonyl chloride. And very important thing, it is also known as Hinsberg reagent. It is called Hinsberg reagent. Aryl, this is your aryl sulphonyl chloride. This reaction is also used for the test of 1 degree, 2 degree, 3 degree amine test. It is used for the test of 1 degree, 2 degree, 3 degree amine. So one by one we will discuss for 1 degree amine. For 1 degree amine, children, so 1 degree amine C2H5 NH2 reacting with benzene sulphonyl chloride C6H5 sulfur, oxygen, and chlorine. Then what is the product? Tell me. Think about it. This sulfur is a poor sulfur because chlorine from 3 side electronegative, more electronegative atom attach, and this oxygen nitrogen is having lone pair. Then this species will attach with sulfur, and chlorine will take electron and leave. So what you are getting? C2H5 nitrogen, 2 hydrogen of nitrogen, nitrogen positive charge because it is donating electron, then sulfur from 2 side oxygen and another side aryl group. Then 1 hydrogen will give sacrifice and positive charge will be vanish. This hydrogen will leave. So ultimately C2H5 nitrogen, 1 hydrogen, sulfur, oxygen, oxygen, and chlorine. The interesting part, this substance reacting with NaOH, or you can say in the base it will dissolve. So here OH will approach the acidic hydrogen, then these electrons shifted on the nitrogen. So C2H5 nitrogen negative sign, sulfur, 2 oxygen, and C6H5, and here sodium plus will be attached. So it is forming a salt which is soluble. So concept is, this is the first phase of the reaction and this is the second phase of the reaction. So this substance dissolve in base, in alkali. this substance is dissolved soluble in alkali. So if the substance is soluble in alkali, then amine is 1 degree. That is the concept. Now for 2 degree, for 2 degree, for 2 degree amine, check it children. Here again C2H5 and nitrogen, one hydrogen and one more C2H5 reacting with again same species C6H5 sulfur, 2 oxygen and chlorine. Again this sulfur is positive sulfur because of 3 side more electronegative atom attached, and here again you are having lone pair. So what happened? Lone pair attached with the sulfur and chlorine will leave. So what we are getting? C2H5, nitrogen is positive sign, C2H5 one side hydrogen, then sulfur double bond and C6H5. So again hydrogen will give sacrifice and positive charge will be vanish, and we are getting C2H5 nitrogen, one more C2H5 sulfur double bond and C6H5. Tell me now, if you are dissolving it in NaOH, dissolving, then what happened? Reaction is not possible. Because why reaction is not possible children? Because this nitrogen this time not having acidic hydrogen, so attachment of OH not possible. Attachment of OH is not possible. So this substance is not dissolved. 2 degree amines are not dissolved in basic solution or alkali solution. So this is the explanation for 2 degree amine. Let's talk about the 3 degree amine. Number C, 3 degree amine. Check it children. So here we are having C2H5 nitrogen, C2H5, C2H5 plus C6H5 double bond chlorine, sulfur positive, and here lone pair. First thing, reaction is not possible. But if it is happening, check it children. Suppose it is happening, these lone pair attached to the sulfur and chlorine leave. So what you will get? C2H5 nitrogen positive sign, C2H5, and here also C2H5 and sulfur and C6H5. So what happened children here? For this positive charge there is no acidic hydrogen available to vanish this positive charge, so again it will take electron from here. What it will do? It will take electron from here and reverse back. So that is why reaction is not possible. Okay, so that's why I told you it's a test for 1 to 3 degree amine. Once again I am repeating. 3 degree no reaction, 2 degree reaction is possible but not dissolve. Once again I am writing 2 degree. I think there will be one confusion in 2 degree. 2 degree amine. So check it one more time. C2H5N, C2H5 and hydrogen, and here it is reacting with C6H5 sulfur double bond oxygen and here chlorine. So this is positive charge sulfur attach and chlorine leave. So what we are getting, C2H5 nitrogen positive charge, C2H5 one hydrogen sulfur oxygen C6H5. So hydrogen will give sacrifice and positive charge will be vanish. C2H5 nitrogen C2H5, then sulfur double bond and C6H5. Now if it is reacting with NaOH, so for the reaction there is no acidic hydrogen present, then not soluble. So that is all about two reactions. First we discuss reaction with nitrous acid. Second we discuss reaction with aryl sulphonyl chloride. That is also called Hinsberg. That is also called Hinsberg reagent. Okay. So that is all about the reaction. So thank you children. Please support me, share my video and subscribe it.